Alright, so this is the first talk on foundations of mathematical proof, and today I want to start off with a basic idea of set theory. So we're going to do some basic definitions of sets, what sets are, and how they come to play in mathematics. So what is a set? Think of a set as a collection of objects. They can be numbers, shapes, functions, strings. They can even be other sets. So a set is just a collection. And the things inside the sets are called the elements of the sets. So a set contains elements. So that's how you can think of a set. Some people like to think of sets as a box. That's an analogy that you might hear when you first start off with set theory. A set is a box, and what the things inside the box are the elements in the set. So we denote sets using curly braces and separate the elements by commas. So example, the set containing the equation x plus 3y, 7 in yellow. That's a set. So there are some basic operations on sets. This sign that looks kind of like an E is it's an elongated epsilon, and it is the element operator. So if A is a set, then X with the epsilon A means that X is an element of A. So I'll just say X is an element of A, and that's a way to shorthand. The absolute value bars that you see here. So if A is a set, the absolute value of A it isn't actually the absolute value, it's the cardinality of the set, which is the number of elements in the set. So absolute value of a set isn't actually the absolute value, it's the cardinality, which is the number of elements in the set. And we'll just deal with finite sets right now for the most part when talking about cardinality, but later on I'll talk about infinite cardinalities. So let A be the set containing 2, 4, 5, and the set containing 8 and 10. So here is where thinking of a set as a box might be good. So think of a box, and inside the box you have 2, 4, and 5, and you have another box inside the box that contains 8 and 10. So 5 is in the box. The cardinality of the set A is 4. You might think it's 5 because 8 and 10. However, that is only a single element. The set 8 that contains 8 and 10 is a single element in A. And likewise, 10 is not an element of A. But the set containing 8 and 10 is an element of A. So right there, even though 10 is inside the box that's in the box called A, 10 is not directly inside the box that contains A. So if you like the box analogy, think of it as, is it actually touching the box? Because if 10 is in the box that's in the box, it's not touching the outer box. So it's not in A. So there are some sets that you really need to know like the back of your hands. So first, the empty set, which we denote with a 0 and a slash through it. It is a set that has no elements. So cardinality 0. This n, the bold-faced n, is the set of natural numbers. It is 1, 2, 3, 4. So these are numbers that you use to count. Set of natural numbers. Z is the set of integers. So it includes your natural numbers, it includes the negatives of the natural numbers, and it includes 0. Q is the set of rational numbers. So any numbers that can be written as an integer over another integer that is not 0. R is the set of real numbers. And C is the set of complex numbers. So these are some of the most used sets, and you really need to know these like the back of your hand. Alright, so set equality and subsets. So let A and B be sets. We say that A is equal to B if every element of A also belongs to B, and every element of B belongs also to A. So two sets are the same if they contain the same elements. So you could write this using our shorthand. A is equal to B if every x in A satisfies x in B, and every x in B satisfies x in A. We say B is a subset of A, and we note that B subset A with the sideways U with the line underneath, if every element of B belongs also to A. So you might shorthand this with our epsilon, saying B subset of A if every x in B satisfies x in A. And notice that B is a subset of B. A set is a subset of itself, and the empty set is a subset of every set. Also, you might see the sideways U with no line underneath it. That denotes a proper subset. So it's a subset that is not equal to the set itself. All right, so let's do a practice problem. We want to prove that the set 6n, such that n is an integer, is a subset of 2k, such that k is an integer. So if you think of 6n, such that n is an integer, that is the set of all multiples of 6. And we want to prove that it's a subset of 2k, and that is all even integers. So the way we do this is we let x in the set 6n. And we want to show that this is indeed in 2k. So it follows that there exists an m in the integers such that x is equal to 6m. X is equal to 2 times 3m. So we just factor that 6 into a 2 times a 3. And since m is an integer and the integers are closed under multiplication, it follows that 3m is also an integer. Thus, x is equal to 2k for some k in the integers, namely that k is equal to 3m. Therefore, x is in the set 2k such that k is an integer, and that square box at the bottom denotes the ends of our proof. And the last thing I want to talk about in this lecture is the power set. So if A is a set, we define the power set of A as a new set such that it is the set B such that B is a subset of A. So the power set will be a set of sets, a set of all subsets of A. So example, the power set of 1, 2, 3 is equal to the set containing the empty set containing 1, set containing 2, set containing 3, set containing 1 and 2, set containing 1 and 3, set containing 2 and 3, and the set containing 1, 2, and 3. So notice in the power set, you include everything as actual sets. So all elements of the power set are sets. And if the cardinality of A is equal to n, then the cardinality of the power set of A is equal to the n. You can think of this as for each element in A, you decide is it in the is it going to be in the subset or not in the subset? And since it can either be in or out for each of them, there are 2 to the n ways that can occur. So that's all I have for this lesson. Stay tuned. I will have more videos up that go more in set theory, and then we'll go into some more proofs. All right, thanks for watching.